The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. This is Dustin Miller with NYMaster Good, and just excited that you all join us here for an overview from the USDA Office of Environmental Markets of the nutrient tracking tool. A couple things to go over as we get started. You'll all be muted throughout this process. If anybody really needs to audioly ask a question, you can do that. However, the easiest thing to do would be to just type a question in the Q&A form within the webinar, within the GoToWebinar function. I'll keep track of those, and as we have time, make sure that Mindy addresses them. Who we have with us today is Mindy Salman, and she is in USDA's Office of Environmental Markets. I'll let her give you a little bit of the background of the tracking tool, but I wanted to give you a little context as to why we offered this webinar. This is really part of the League's Conservation Innovation Grant that is finishing up. It was a 3-year grant that we received in 2015, and in the fall of 2015, it will be finishing up here in the fall of 2018. And the whole goal was to create a market-like structure similar to water quality credit trading, and where with our stakeholder groups, which some of you that are on the phone are joining us know, where we've landed is on the creation of an Iowa nutrient reduction exchange, where rather than developing water quality credits, we're registering nutrient reductions. And part of registering reductions and practices, part of that portion, which today is not the time that we're going to go through the exchange. More information will be coming on that through the summer. But a portion of registering practices is making sure that those practices are monitored. And one of the easier tools that Iowa State, DNR, and IDALS, Iowa Department of Ag and Land Stewardship, have landed on is the tool that Mindy is going to go through. So for those of you that are city officials or employees, or those of you that are engineering consulting firms that may be looking at practices and how you would get them into the nutrient reduction exchange, the nutrient tracking tool is going to be a tool that DNR and IDALS and Iowa State will recognize as something to model those practices. So with that, I'm going to kick it over to Mindy to give you guys an hour overview. And as I said, if you have questions, just make sure to use that chat bar. And I'll try and interrupt Mindy, and we'll get to them. But thanks. Thanks, Mindy. Go ahead. Mindy, are you there?
Oh, sorry. I was talking. I was on mute. Sorry about that. So thanks, Dustin. And as he mentioned, I'm Mindy Salman, and I'm with the Office of Environmental Markets. And I've been leading the development of the nutrient tracking tool along with our partner, the Texas Institute of Applied Environmental Research at Tarleton State University. They're the modelers and developers of this tool. A little bit of background about the nutrient tracking tool. It was first developed as a proof of concept back in 2008 through 2010 as a partnership with NRCS and TIER, the Texas Institute of Applied Environmental Research. And it was, and from that sort of proof of concept, there were a couple other iterations of the tool that were developed, and one was for the Chesapeake Bay region, sort of its own standalone Chesapeake Bay nutrient tracking tool that incorporates a lot of the nutrient trading rules and regs into that tool, so it's very location specific in that way. And also some improvements to the NTT tool that TIER did on its own. And what our office did was, our office is charged with helping to develop the tools and registries that can help facilitate markets. And we wanted to have a national scale tool that could estimate nitrogen, phosphorus, and sediment losses from agricultural land. So we wanted to take that tool and expand it nationally and create a better user interface, make it easier to use. So that's what we've been working on for the last, we worked on that, and we really, for about a year and a half, with TIER and released this tool, a soft release in January. So that's what I'm going to be demonstrating for you today. Our office supported the development of this tool as a science behind water quality trading, but that said, it has a lot of other applications, potentially corporate sustainability and supply chain sustainability type of programs, also education and outreach, planning, and research and analysis we see as also being able, other uses of this tool. Users of this tool, we see producers and organizations that might be interested in trading programs or ag certainty programs, such as in Maryland is using this also for their ag certainty program. Also just those that are interested in looking at this tool as a way to look at the economic and environmental outcomes from their management practices. Also agribusinesses, crop consultants and aggregators, and others like NGOs and academics might have a use for this tool. So to get a little bit technical on what's the model behind this tool, NTT uses the Agricultural Policy Environmental Extender Model, also known as the APEX model. That's the same model that's used in the SEEP evaluations by NRCS, although this version of the model is a slightly different version than what would be used in SEEP. We've sort of taken a version and held it at a steady state in order to make sure that we do the error trapping that we need to do. The APEX model uses a lot of spatial data to provision the model and get the site-specific answers for your field. Those data include the National Soils Database, so the Servo database of soils. Also, the PRISM Climate Database is used to look at the weather. And then also we use a 30 resolution digital elevation model data to look at slopes. I want to talk a little bit about the parameterization and validation of the model. Of course, the United States is very large, so we know that APEX ideally would be parameterized locally for each of these areas. We are using, this model was released with some generic parameters that were developed by Blackland Labs, the same people that do SEEP. But that said, we are in the process of going through state by state to try and hone those parameters in on more state level functions. And there's our state level parameters or production patterns. So what that process is we are, it's a two-step process. And for the first step, we're looking sort of at a broad state or ecoregion level, and we're looking at the available data that we can get from NASS. Most of that will be on yield. Also maybe some flow data from USGS. And we would run the model to make sure that we are at least accurate within your state or region for yields and flows. And then that would sort of be a preliminary set of parameters. So that might involve some tweaking of the generic parameters. And then what we're hoping to do is for states or regions that have field level studies that we can use that look at nitrogen, phosphorus, and sediment losses or sediment losses, we would be using those to more precisely parameterize the tool. So we've done that for Ohio, where we had about 8 site level studies that we could use to parameterize the model. And that's a lot more involved as a process where we mimic the field conditions on those sites and try to match the measured data. And from the site level parameters that get developed, we broaden those out on the regional level to make sure that they fit for the region, and might have to do some additional regionalization of those parameters that we developed at the site scale. So as I mentioned, the one place that's been done in the tool so far is Ohio, and we're starting the state level parameterizations, and I actually prioritized Iowa as one of those, and that should be done in a couple weeks. Yeah, so we're looking at doing that. We also have some site level data that we're going to be working with in the Pacific Northwest, Wisconsin, and California that will be doing some of the finer tuned data. And Actually, based on a call yesterday, there's some data from Iowa that we're possibly going to be getting soon that we can start that more detailed parameterization of the tool for Iowa as well. All right, so without further ado, I'm going to go ahead and show you the tool. This is the login page. It kind of has a long address. It's ntt.tier.tarleton.edu, and that brings you to this home page. If you're a new user, you just click the new user button and it'll ask you to establish a username and password. There's some information here on the bottom. You'll see this link called page instructions, and on any page within the tool, you can click that and it'll kind of show you what's happening on the page and what kind of inputs you need to put in there. Documentation is a PDF of the documentation. FAQs, contact us. This is some information about NTT and the Apex model. This is where we'll announce what's new, is where we will announce when we're doing updates or upgrades to the model or to the tool. This is some video presentations that you can look at for help, and some more contact information. I'm going to go ahead and sign in. So when I sign in, I come to my account, and in your my account or your account, if you were to log in, you'll have a list of all the projects that you've created. And of course, I've created a lot because I've been working and testing this tool for a while now. And from these projects, you can manage them in this page. You can download the project files to your home computer. You can edit the name of the project. You can copy that project. So if you have a project you don't want to mess with, but the original, but you want to make a copy of it and do some changes, you can do that here, or you can delete the project. By clicking on the project name, that's when you open the project and can go into it and start editing it. Create new project allows you to start a new project, and upload project would be if you say you had downloaded the project files to your computer and then wanted to upload that separately. So if you don't want to keep your project online, or if you want to send your project to somebody else to look at, you can download it and then they can upload it. Download it and send it to them, and then they can upload it in their own account. I'm going to go ahead. I'm going to open a project that I've already done, only because the USDA internet has been a little slow. So I wanted to make sure I had some projects that had already been run, so that I wasn't wasting your time by with our internet connection. So when you create a new project, you're going to be asked to name that project. And then once you name it, you're going to be directed to this location tab. And you can zoom in. You'll get a map of the US, and you can zoom in several different ways. You can either put in an address, which could be a full address or just a city-state. You can put in a lat-long in the decimal format if you have the lat-long. You can just select a state and county. Or you can just do the manual zooming on the map with these plus or minuses. Another way you can create fields on your in this map is to upload a shapefile. So if you have a shapefile, you can just do that pretty easily. Just select the file and upload it, and it'll draw the fields on your map from that shapefile. I'm going to be manually drawing a field. To manually draw a field, you would click this polygon, and you're just going to start clicking the corners of your field. Sorry. And once it's closed, the polygon's closed, it's going to ask you to name it. And you can always change the shape of the field by pulling on the those buttons. And once you're finished drawing your fields, you would click submit. And what it's doing in the back end is it is pulling the weather file, it's pulling the weather that's associated with that field, it's pulling the soils associated with that field, and it's calculating the slope for that field. And then you're going to come to this list of all of your fields. And I've I've already populated scenarios for fields 1 through 3. So I'm going to go ahead and pick on field 1. So what's going to happen is you're going to go into each field and you're going to describe the management scenarios for that field. And here's where my internet's slow. So what it's going to do is it's going to pull the soils and show you the soils for this field that it selected. So for this field 1, it is showing me these soils, and we only choose the top 3 soils. So if you had 5 soils on your field, we're just going to show the top 3 by percent cover for that field. And that's because NTT basically does a run for every soil. So in order to minimize the processing time, we've just chosen the top 3, which usually accounts for the 80 to 90% of the soils that are on that field. So it's pulling this from the Sergo database. We just sort of give you some general information: the name of the soil, the class, the slope. Again, this slope is calculated through the digital elevation model, so we're overriding the slope. The slopes is so 2 to 6% slopes, but we've calculated at actually 3.137%. So we do that. That's the calculated slope, and then the organic matter. This is the value that comes from the Sergo database, but we found that the Apex model is actually very sensitive to organic matter, and a lot of times this organic matter isn't representative of what's on the farm or in the field. So this is the one parameter that we allow you to change in the soil. So if you have better information on your organic matter, you can change it here. And this is the percent cover of the soil on your field. The other things you can edit here is the field area. This, of course, is calculated through the map. But if you incorrectly drew your boundaries, or this is really a 240-acre acre field, you can just make that adjustment here. The other thing that we're asking for is the soil p-test, which helps give a starting phosphorus value for the soil. You might not have a test, and you can select none, and that'll just default to a starting p-value for your soil. But if you do have a test, just select your test type and put in the value here. And then click Save and Continue. And you're going to come to this Management Scenarios screen. And I've already developed some scenarios for this field. So you can do one or more management scenarios for the field. So if you could do what you're currently doing, and then you could have another scenario that looks at, well, what if I switched from corn soybean to hay, or what if I put in a buffer strip, or what if I started incorporating my manure, or what if I switched to commercial fertilizer. So there's lots of different scenarios that you can run. I'm going to go ahead and add a new scenario so you can see what it's like to build a scenario from scratch. So we've tried to make this as easy as possible. So you're going to add a crop to the your scenario is going to show your rotation, or your management scenario. You need to build your rotation. So let's just do corn, and then you're going to select a tillage type. I'll do intensive tillage, and I'm going to plant that in the first year of my rotation. And I'm going to upload it. And what's going to happen is what we pull in is a bunch of default values that you can modify as needed or as desired. So we're going to give you kind of a standard planting date for that crop, fertilizer application for that crop, tillage. This tillage is based on if you selected intensive, reduced, or no-till. If you selected no-till, there will actually be no tillage operations for this field. Harvest date and end of crop season. This end of crop season is actually for the model to know that after you harvest the crop, you're actually no longer growing the crop. So it's for annual crops like corn and soybean, where after it's harvested, the crop ends on the field versus hay, which it's going to grow back the next year. So this basically removes it from the model scenario, or from the modeling. In the modeling piece, it kind of lets the model know that the crop is done for the season. Okay, so when you want to go ahead and edit this, so say your planting date isn't really May 5th, you can click this edit button, the little pencil, And you can change that. So maybe it's actually May 15th on a typical year, and then finish, and it's going to update that planting year. And say this fertilizer, 180 pounds we apply in the spring. Maybe you do a split application for that. So maybe you really are only applying 50 pounds of starter fertilizer, and maybe you're incorporating that. Maybe you're knifing it in at 3 inches. You can do that. And now I have my phosphorus. Let's say I'm also knifing in my phosphorus. I'm also incorporating that at the same time. And then I have an application that I do in June as a side dress. Commercial fertilizer. You have some choices too. You could also apply manure. So like beef manure, it's going to give me some defaults for the nitrogen and phosphorus concentration in that manure, which you can change if you know your manure content better. And then your application rate and the depth if you're incorporating that. You can also do liquid manure, which is going to ask you to give the values in 1,000 gallons, pounds per 1,000 gallons. But I'm going to go ahead and stick with commercial fertilizer. And you can choose your fertilizer type, or you can just do the elemental. I do elemental because it's easier. The math is easier for me. But if you were to do one of these, it would actually be applying both nitrogen and phosphate at these rates. So let's say I'm doing 130 pounds in June as a side dress, and I'm not incorporating that. So zero for my depth. So now I have a spring application that's incorporated at 3 inches and then a side dress. You can also do things like delete tillage. You can delete an operation here. You could edit this. If you don't do a chisel plow, you do something else. Maybe you do the harrow or some kind of disking or something. You can change that as well. And we tried to sort of trim down the drop-down list to make it simpler and be more sort of categories of equipment instead of being very specific, because it can take a long time to go through a big, long list of 100 pieces of equipment. So we tried to trim it down. So if I'm satisfied with that, I can go ahead and click Continue. And this is where I have conservation practices. So right now, what we have is we have auto irrigation and auto fertigation. Sorry, I actually want to show you something else first. If I go back to this crop rotation, first of all, I want to show you how you can add a second crop to your rotation. So say I do corn and then soy, and I just do that in my second year of my rotation. I can upload that. So you can build multiple crops into your rotation. And another thing you can do is you can add something like a cover crop. So say I do a rye cover crop after corn, so in year 1, October 15. So I plant it after I pull off my corn, and I use a broadcast seeder to do that. So I can add that cover crop. It's going to place it in between the corn and soybean. Now, when you add a cover crop, it really is just assuming you plant it, you let it grow, and you remove it before soybeans comes in, and you're not harvesting it for commercially harvesting it, and you're not applying any fertilizer to it. If you actually do have a commercial winter crop, you can go to add crop to rotation and say you do winter wheat. You could add a winter wheat rotation after year 1. So here you'd have your winter wheat, and it's going to show that you do fertilizer or tillage, and you'll have a harvest. So I'm going to just delete that for now. The other thing I wanted to show you is that, so you have a bunch of operations that are categories of operations here that you can go in and edit or add new ones. But if there's a different operation you want to add, you can actually just add one from scratch, and you can do a manual irrigation. So this would be a one-time irrigation, a grazing operation if you if you either have pasture or maybe you graze the cornfield after you harvest, burning and liming. And these other ones you've seen, the planting, fertilizer, tillage, you've seen those, but there are some additional operations that you can add. Okay, so now I'm going to go ahead and continue. Sorry about that. So these are sort of the structural practices and conservation practices that might be on your field. So first we have auto irrigation and auto fertigation. This is going to set up an automated irrigation feature for your field, and it's going to irrigate or fertigate according to parameters that you give it. So first you'll tell us, let's do auto fertigation. It'll ask you what kind of irrigation you do. So right now we have these 4 broad categories: sprinkler, furrow flood, drip, and furrow diking. So say you have a sprinkler, and it's going to ask for the efficiency. We tell you the range of efficiency of that type of irrigation, and you can either just take the default, or if you know better what the irrigation efficiency is, you can put it there. This is going to ask for the maximum interval between irrigation. So if you set this at 1 day, it's gonna know that it can irrigate every day. If you set it at 7, it's going to know that it can only irrigate at maximum every 7 days. So let's put that at 1, so it can irrigate at will. Percent allowable plant water stress. So this is, say I only want to irrigate when my plants are 20% stressed, or they can't be more than 20% stressed before irrigation happens. So I don't want them to get down to 30% water stress. So you can set this at 0% stress, and then it would irrigate. Then the water stress would not be a limiting factor. Maximum single application. So this would be, especially in the western states, if they have sort of an allocation of water that they can apply at any given time. And then an application rate. This is because I chose fertigation. This is going to ask for the fertilizer, the total pounds of nitrogen that it's applying per acre. And if you do auto irrigation, that last question isn't there about the nitrogen content. Tile drain, this is going to ask if you have a tile drain, and if you do, what's the depth of that drain. I'll go ahead and put a tile drain on ours. A wetland, so this is if you have a wetland or implementing a wetland, how many acres is that wetland? And the other thing we ask is if that wetland is already included in your area of interest that you defined for the field. This is because we found that different people draw the field different ways. A lot of times if the wetland is already existing, it wouldn't be included in the field, but if it's something you're considering as a BMP in the future, it might have been included in the original area of the field, but it might be a portion of that field that you want to carve out to be a wetland. So we have this question: is it already included in your area of interest or not? And that'll change a little bit how it's modeled on the back end. So if it's not included in the AOI, we just sort of, kind of create an instance of a wetland and have your field drain into it. If it actually is included in your AOI, then we'll carve out a piece of that field and subtract it from the total area of the field and put that wetland in there. So you just tell us the acres, and then you just tell us if it's already part of that AOI or not. Ponds or water and sediment control basins are considered to be within field, not adjacent to field. So we're just asking at this point what fraction of the field is controlled by that pond or water and sediment control basin. Grass buffers, forest buffers, or filter strips. You just tell us here if it's just a grass buffer or if it's a forest buffer. If it's a grass buffer, we want to know the type of grass that's growing there. So say Bermuda, the acres of that of the buffer, and how wide is that grass, the strip in feet. And then the fraction of the field that's controlled by the buffer. So maybe about a quarter of the field is drains to that buffer. And then again, is the buffer in the AOI or not? And then if you have a forest buffer, we're asking a lot of the same questions, except the assumption is that a lot of times a forest buffer has a piece of grass or a strip of grass and then the forested piece. So we're asking both you to describe that grass strip and the forest strip. If you actually don't have a grass strip, then you can just say 0, I don't have one. And then the width of the forest strip, you could put right there. So, but I'm not gonna do that one. So next is the grassed waterway. So this would be within field. Tell us the type of grass that's in that waterway, the width of the waterway. This would be edge to edge, that width, and then the fraction of the field is treated by the waterway. Contour buffer. So this is assuming a permanent vegetated buffer strip in between your as a buffer in between the different fields or different if you're doing strip cropping. So just tell us the type of vegetation that's in that strip, the width of the grass strip or the buffer strip, and then the width of the crop strip. And it's going to divide your field into alternating crop and buffer strips and route the water between those strips. Land leveling, you just tell us the slope reduction. That's probably, I don't know that that's something that Iowa does. It's more some places that do cotton. And then terracing system, if you have a terracing system, you just check that on or off. So I can go ahead and save and continue, and now I have that scenario here. I can copy that scenario. If I want to do the exact same thing, but just tweak a couple things, I can just copy that whole thing and then just make some modifications. So if I wanted to do everything that I'm currently doing, but put in that cover crop, right. Can upload. Taking a while. Sorry, this is the USDA internet. And let me know if last time I did one of these, the internet went down on my end and I didn't even realize it. And so it kicked everybody off the webinar. So anyway, I've added that in. So I can continue that. And then I might want to rename this at that point. I want to call this test scenario cover crop. So I know that it's the same scenario, but with a cover crop. So you can, copying down the scenarios really speeds up a lot of that work. And then once you're done with your scenarios, you're going to select them and you're going to do the simulate selected scenario. And this is where, because our internet's slow, I'm not going to do that because it can take a little bit of time even when your internet's not slow. Because what it's doing is it's writing the files that based on your management scenarios and the weather and the soils, it's writing all those files, packaging them, sending them to the Apex model. The Apex model is running them for over 35 years of weather that it got from that weather, the weather station. And over each one of those soils, so for 3 soils, 35 years for each of the management scenarios. So if I were to run 2 scenarios, each one with 3 soils, it's going to be running Apex 6 times over 35 years each. So it can take a little bit of time, especially if you're simulating multiple scenarios. And once it's simulated, you'll get this simulation date, so you'll know that it's been run. And then you can view results of your scenarios. So I'm going to go ahead and view results. And there's a couple different ways you can view results. You can view it as a tabular view, and then you can look at, there's 2 different types of charts you can look at, either charts by year or charts by month, average monthly. So I'm going to go, and you select your scenarios that you want to look at. I'm going to look at corn baseline, which when I created that, it's just a straight corn rotation with all the fertilizer applied in the spring and heavy tillage so intensive tillage, sorry. So intensive tillage, all the fertilizer applied in spring, so no split application or anything. And then I'm going to do split application with incorporation and a cover crop. And also I think it's no-till as well. And then I'm going to do split application with incorporation, cover crop, and a buffer. So those are the three I'm going to compare. So then I get my results in this chart, and I can see that my losses of nitrogen for just intensive tillage on corn with all my fertilizer applied in the spring and no incorporation, I get about 24 pounds of nitrogen loss. This is my 35-year average. Sorry, you can click that and get the expanded. And then when I did a split application and incorporated and added a cover crop, my losses went down to 11.1 pounds. Sorry. And that's a total of, I reduced my losses by 12.9 pounds per acre, and that's a total of a 53.8% reduction. And then when I did when I added in the buffer, I went down to 9.9 pounds, so I actually didn't gain that much. I reduced another about 1.2 pounds between this and, between those two, I reduced about 1.2 pounds, but total, the difference is always done from the first scenario. So it'll always be comparing to the first scenario. So compared to the first scenario with the buffer, I reduced 14.1 pounds. And then you can also look at how those losses, that summary line, the total nitrogen is actually composed of organic N, runoff N, subsurface N, and tile drain N. So you can look at how the loss pathways for nitrogen were impacted by your best management practices. And a lot of times what you might find, especially if you go from intensive tillage to no-till or include something like cover crop, you might find that your runoff N gets reduced, but you might get a little bump in some of the subsurface and tile drain N, even though the overall reductions are going to be there for the most part. So you can expand any one of these. So you can look at your loss pathways for phosphorus and so here you see a little bump in the tile drain N between the two when we did the incorporation and no-till. Subsurface and tile drain flow, so you can look at the flow in inches, and you can see that the flow increased to subsurface and tile drain. And then other water info, this is going to be if you had irrigation, it would show your irrigation, how many inches were applied in irrigation, and your deep percolation. And then sediment is going to include both the surface erosion, and if you applied manure, it's going to show you how much of that manure was washed off. And then the crop yield. Sorry, I'm just going to collapse some of these. You can look at how your crop yield is impacted. So we can see that when I applied all my fertilizer in the spring and I did intensive tillage, I had 156 bushels per acre, and then when I incorporated, did a split application with incorporation and a cover crop, I actually got a bump in yield. And there's no change between these two in yield, of course, because the buffer was outside of my AOI. It's not impacting the yield. Another thing to note here is you can look at it right now. I've been looking at it on a per acre basis, these values. I find that easier to digest, but you can also look at it on the total area. And so this is going to multiply it up by the area of your field rather. So I can't remember, this was 200 and some acres, 240 acres. So it's multiplying everything by that acreage. So just to show you the annual charts here. Sorry, our internet's slow. Okay. So for the annual charts, we just added in this feature where you can actually choose the years that you want to look at. So say I want to look just from 2000 to 2015. I still want to look at these 3 scenarios, and I want to look at nitrogen losses. I want to look at my runoff N. So it's going to show me a chart, and you'll see that the runoff N is heavy on my corn baseline, and for the other, because of the axis, you can hardly even see the runoff N for the for some of these for the other 2 scenarios. I wonder if something like tile drain N. Tile drain N is a little bit more even. So you can look at how the 2 scenarios stacked up. And again, because the only difference between the split application with cover crop and the yellow one, which is the split application with cover crop and buffer, that buffer is not really impacting. It only impacts the edge, the losses at the runoff end. It wouldn't impact the tile drain end. So that's why they're even or almost even. You can look at things like precipitation, so you can see what was the rainfall in those years. So you can see what that is. The next thing you can look at is monthly charts. Now this is going to do it by month, and there's fewer parameters that you can look at and summarize on a monthly basis, and that's because of Apex doesn't summarize as many parameters on a monthly basis. But maybe you want to look at organic N. These are really low values. It's going to scale different. So you can look at how that is. You can see these losses are clustered around the growing season. And yeah, so this is going to be the 35-year average losses for April and the 35-year average loss for May. So these are average, like the tabular, it's the average over the 35 years, but it's split into months. All right, very quickly, I just wanted to show you another field where I did pasture, so you can look at what pasture looks like. I haven't looked to see if there's anything in the chat box. Are there any questions?
I haven't seen any come through, Mindy.
Okay. All right, so so I'm on field 3 now, which when I put the information into this one, I made it into a pasture, or I did pasture scenarios on this. Save and continues. Sorry, my internet's so slow today. All right, so I have this pasture current where I planted pasture. You just plant it once and it sort of assumes it comes back every year. It's a permanent pasture planting. And then I did continuous grazing. So the continuous grazing operation is going to ask you the start date of when you graze and the end date when you graze. So I'm starting in June and ending in September. I'm going to graze beef. Then you have we probably should take off turkey and duck off there, but you have the animal type there. And then the total animal units that you're grazing and the hours per day that you're grazing. And it's going to just put the animals out there and assume that they're grazing continuously. For my other one, rotational grazing, I've added a rotational grazing operation. So I again did from June to September beef. I think I put the wrong animal units in. 200 animal units, 24 hours a day. But the other additional information that it asks for is how many days are consecutively spent in each paddock. So I'm going to say 2 days in each paddock, and that there's a 14-day rest between when that paddock gets used again. So what it's doing in the back end is it's dividing that field into however many paddocks that would equal, and it's going to rotate the cattle through that paddock system for that entire period of grazing, so June through September. Sorry, this is taking so long. thinking about it. All right. Okay, I'm going to go to view results. And it always asks you to put in 3 scenarios, and I only had 2 to look at. So I'm just putting rotational grazing in 2 times. And you can see how the losses between continuous grazing and rotational grazing, it seems the reduction in nitrogen and phosphorus goes down between those 2 grazing systems. When all I did was change my grazing from continuous to rotational. So with that, I think I've gone over most of the features. There's one more feature that I wasn't planning on showing you today, but I'll tell you a little bit about it. I'm not going to do it because my internet's so slow, it probably would take 10 minutes to run it. But we have this feature called field routing, and this will allow you to, right now when you're looking at the results for the fields, you're looking at the results at the edge of that field. But if you actually wanted to look at, if you know that water flows from field 1 to field 2, and you want to look at that routing effect, like what's happening as the water routes from one to another. So basically setting up a small watershed, you can set up a little project, like a little watershed, and you can add fields to that. So if I want to say field 1, the corn baseline scenario, that then that routes into my continuous grazing pasture, and I want to look at how my losses are from, if I look at it just from going from that cornfield to the pasture, and what the losses are at the outlet of the pasture. And so what that's doing is it's going to look at some of the attenuation effects of the losses from the cornfield as it attenuates over the pasture field. So a lot of times you'll see that those losses are going to be less than the sum of the 2 edge of field losses, if that makes any sense, because there's attenuation that's going to happen to the fields that are upland of the final outlet field. So
Mindy,
you can look
if you have a second, we do have a few questions that Heather can read.
Yep.
Okay, so the first one that came in was asking about management options. Will management options for urban land be available in this tool? You mentioned this tool was primarily for agricultural practices. Curious because the performance of the conservation practices will be different in an urban versus rural setting.
Right, yeah, this right now is just for agriculture. I know Tarleton has been working on an urban tool. That's not something our office has been funding, but they do have, for the Chesapeake Bay, they've been looking at an urban thing. So they might have some tools that might be integrated into this at a later date, but our office has only funded the agricultural piece to it.
And let me add to that, Mindy. This portion is related to the Ag BMPs, but through our work on the Iowa Nutrient Reduction Exchange, there's been a lot of models, so if people are interested, they can reach out directly to me. And part of our project is the University of Iowa and Flood Center, as well as we have a lot of interaction with Iowa State. So we can talk through, Step L modeling, other, Mike Shee, things that have gone through review with DNR, IDALS, and Iowa State that gives people a certain level of comfortability. But as far as the urban stormwater practices, you can feel free to reach out to me directly on that.
Okay, our next question. Does the tool differentiate between a restored pothole wetland, which does not receive tile flows, and a breakpoint wetland where drainage has intentionally directed to the site for nutrient removal?
I would have to refer to our modeler for that. I would probably have to get back to you. I think that that would probably have to be categorized by the, or if I'm understanding correctly, you're saying, so some might be a pothole wetland that's really not like a catch basin versus one that's like getting flow directed to it as a treatment. that might be captured in when you put in the percent of field that is treated by the wetland. Like something like a pothole wetland might like treat 1% of the field or something. It might be a very small fraction of the field because it's not really drawing from a basin, versus a treatment wetland might treat like 40% of the field. So that might be one way, but I would have to confer with our with the modeler.
Okay, these next two are from Jamie. So Jamie, if I'm not representing them, let me know. What about bioreactors and saturated buffers? Will you be adding these practices?
Yeah, so we talked about that yesterday with the call with Jamie and Adam. And I did, so those are two practices that I guess Iowa is really looking at and is not captured in our tool at the moment. But I talked to our modeler yesterday, and he seemed to think that it would be fairly easy to add, and it might be something very simple, like you would check if you had one of those features, and it would add a reduction to the tile drain N, because I think those are treating just the tile drain nitrogen. But at any rate, we could work with Iowa State to kind of get the parameters around how that BMP would work and put that into the model. I think it'd be fairly easy to do. So yeah, that's something we're looking into and would hope to do.
Next question. Jamie says, thanks. Can program and data be downloaded to run on your own computer, or must it run via the internet?
So you can download that data like I showed you. You can download oh, it's so slow. Anyway, when you saw the list of projects at the very beginning, the dashboard that you get when you first log in, there's a little download button, so you can download the files. But what you're downloading here is you're going to be downloading the with this little arrow button. You're going to be downloading the Apex files, which are going to be like a series of about 20 text files or more, because you have like several projects, probably several different management scenarios that you're downloading at that same time. So my point being, if you have Apex on your machine, then yeah, you could run it on your machine. But if you don't have Apex on your machine, no, probably not. I don't think you could. But that is there because there are some researchers that do have versions of Apex on their machine, so they could run it on their machine. But if you don't, then yeah, you'd have to run it up here, run it, like import it back into this application and run it. If that made sense.
The next question, does all of this information need to be filled out all of the time, or can producers leave some of it blank and have the model make assumptions? It's a lot of information to enter.
It does require most of the fields that are asking for data are required, but that's why we have a lot of the copy features. Like you can copy projects, you can copy management scenarios down. We have the pre-populated information for each crop, so that you could just sort of run a very generalized no-till, reduced-till type of scenario without changing anything in the run if you didn't want to. And I do that quite often just to get like a thumbnail sketch of what the reductions are if I switch tillage types or if I switch crop types. So we've tried to kind of create as many defaults and pre-populated fields as we can. But it is a very data intensive model, and we know there's always a balance between people wanting precision and people wanting ease of use. So we hope we struck a good balance between those two.
I'm going to skip forward to another data-related question. Does the data entered remain private, or is it publicly available? How secure is the data which is specific to individuals?
Yeah, well, this is secure. Like your data is only viewable by you. It's password protected. If you want to share data, you can use the download button and email those files to somebody else who can then open your project. So yeah, it's password protected. It's on a secure server. It's also important to note too that, you know, for instance, all of these projects that I've created are not real farms or not real farm data. A lot of people will be using this as a way to sort of explore and you know, evaluate different scenarios, but aren't necessarily going to be what the farmer's actually doing. And there's no way of knowing for anybody to know what was real farm data and what wasn't real farm data. But that said, it is all protected. It's all password protected, and it's all associated with your account. And nobody sees it except for you unless you download and share the files outside of the program.
Okay, on to another one. Can you analyze wetland performance or inundation duration with this tool?
I don't think so. So no, I would have to again ask the modeler exactly how the wetland that was what was it, inundation?
Inundation duration, wetland performance, or inundation duration.
Yeah, no, you can't. The wetland, again, the wetland performance is all put it, you know, basically the user says my wetland is treating 30% of the field, and I think what the wetland is, it models sort of like a pond that has like vegetation growing in it. So the vegetation is doing the nitrogen uptake. It's not a precise, it doesn't look precisely at like how often the wetland's inundated and all that kind of stuff. It's more rough than that.
All right. Will there be options for adding custom management tools so that it can be adapted to urban or semi-rural management tools?
I mean, possibly. We're always open to improving the model. So I guess I would have to know exactly what types of modifications or other tools that you would be interested in adding. USDA has been sponsoring the development of this, but it is, you know, housed at tier, and it's their tool. And this is a national level tool, so we also probably won't be making it too region specific or program specific in those terms. But certainly if there's different best management practices or some processes, I know some people have talked about adding drain mod, or our modeler has actually talked about an ability to add drain mod into this as a subroutine. That would be something we'd be interested in doing.
Looks like that's all the questions that are in this session now. If there are any further ones, go ahead and enter them. There's one more, sorry. Can you explain a little more about the water routing watershed feature? Is there a limit to the number of fields that you can link?
I don't know what the limit is, but I know that they've done it for a very large area. Kind of like they've been able to run basically like HUC12 in this tool. Like, so they imported a shapefile with like a HUC12 and segmented it into basins and ran it that way. I can, again, would refer you to, I can follow up with you with our modeler, but I know that it has been able to do larger ones. And of course, if you're using an offline version of this, it might be a little bit easier to run the bigger watersheds, but Apex can do watershed scale. So it might take a little bit more processing time, which is maybe why the web-based version isn't as ideal for it, but it can be done. But again, I don't know what the limit is for the size, so I would have to get back to you on that.
Okay, that was Jamie asking that question again, but he seemed to be okay with it. That's the last of them.
All right. Well, thank you everybody for having me. We wrapped up in like exactly an hour, so I'm super impressed with us. I think, go ahead.
Go ahead, Dave. Go ahead, Mindy.
Oh, I was just going to say, I think, Dustin, you have my email, and I think it was probably on the invitation, but you can send it around, or if people have questions specifically for me or would like me to follow up with them, like, I guess email Dustin, who can put us in contact.
Yeah. And the one thing I would say is, for those of you interested in, how this translates to the Iowa Nutrient Reduction Exchange, more info, the pieces are coming together, and more info will be coming through this summer, and probably a full-fledged launch in September timeframe. So thank you all for taking your time. If you don't have my email, it is dmiller@nyemaster, like Bill Nye the Science Guy, nyemaster.com. And you can find me on the website. So thank you guys for taking some time today, and we'll talk to you soon. Thanks, Heather.
Thanks.